Well, hello, fellow aviation enthusiasts, and welcome back to SkyBound on the Ground with Michael Lombard. My name is Michael Lombard. We've learned a lot about aerodynamics in the last few lessons, and now we're going to take that on a practical level and learn how to actually control an airplane while it's flying. Is that something that would be good for pilots to be able to understand, right? Well, today's lesson is based on the Pilot's Handbook of Aeronautical Knowledge, Chapter 5, called Flight Controls. So we're going to learn about flight controls today, and to do that, let's take a look at the airplane. And this takes us back to chapter 1, to lesson 1 when we talked about airplane components. And we're going to review what the flight controls are. We're going to talk about the 3 primary flight controls. And so we got our wings out here. And what kind of flight controls do we have on the wings? Remember, we have these hinged surfaces out here. And what were these called? These were called ailerons. And I looked up the word. It is definitely from the French. And I guess it meant something like little wings. So we have these little wings on the large wings, and they are hinged surfaces. So when you deflect them, when you deflect the ailerons, that's how you bank an airplane. So you maneuver the airplane on its longitudinal axis by rolling it using the ailerons. All right, so that's the ailerons there. We have the horizontal stabilizer in the back of the airplane. And what does that have? It also has a hinged surface on it, and we call that elevator. We call that the elevator. And the elevator is used to basically elevate the pitch of the nose. And it doesn't elevate the airplane like this, but you can raise the nose or lower the nose by deflecting the elevator control. And then we have one more thing in the back here. This is our third primary control. And this is a little bit more familiar to most of us, and that is the rudder. You've probably seen these on boats and ships and stuff. And we also have it on airplanes, I guess because airplanes are the ships of the sky. So yeah, let's learn how to sail our ship in the air, the wide sea of the air. Anyway, so these are our 3 primary controls, and we have something in the cockpit whereby we control these things. We actually have 2 things. So the first one, it looks kind of like a half steering wheel, and we call this the yoke. And you can turn it like a steering wheel. You can also push it in and pull it out. And so when you turn it, you are actually actuating the ailerons, and when you push it in and when you pull it back, then you are actuating the elevators. So that's our control yoke, and then you have down here where your feet are, you have 2 pedals, and no, this is not gas and brake. They actually are hooked up to the rudder. And so when you push the rudder, right rudder, left rudder, that will deflect the rudder either direction. And these are all hooked up by mechanical linkages. You'll have like these cables and pulleys and a system of that, and so that'll go and that'll be hooked up to actuating rods, and that's how the yoke and the rudder pedals are hooked up to the actual flight controls. When you get to larger airplanes, then you have these hydraulic things that assist because you have larger controls that you have to move. And then sometimes you can get to fly-by-wire, where instead of having a actual physical connection between the controls and the control surfaces, you'll have electrical wires that go there, and they control a motor that moves the flight surfaces. So anyway, for the airplanes that you and I are going to be flying, you just have mechanical linkages, and so when you move the flight controls, then you are moving the flight control surfaces. These are the surfaces over here, and these are the controls. So ailerons, elevators, rudders, those are our primary flight controls. How in the world do they even work? How do they maneuver an airplane while it's flying? And this takes us back to aerodynamics. Aren't you glad you studied aerodynamics in the past 3 lessons? Because now we can understand how this works. So let's take a look at the side of the wing, and let's use an aileron for an example. So here's the wing itself, and then at the very back you have that hinged surface, which is the aileron. So normally when the airplane's flying through the air, you have this airflow that's going over. What's going to happen when you deflect that aileron? So here's what it's going to look like in the first place. Let's say this is the wing, and you're going to deflect your aileron downwards. So we're pointing our aileron downwards. And what is that going to do? Okay, so let's take a look here. We've pointed the aileron downwards. Now the air is flowing over, and it gets deflected down more, and you're producing more lift. So when you have the aileron pointing downwards, that part of the airplane is going to want to rise up because you're producing more lift on that side. The opposite is true if you raise the aileron. So if you raise the aileron, now you're kind of producing resistance on the top, and you're kind of destroying some of the lift. And so in that case, the wing or the surface is going to want to fly downwards. So let's take a look at this when we want to roll our airplane into a turn. So here's a back view of the airplane. That's the tail, by the way. And okay, and so here are our wings. What's going to happen? How should we deflect our ailerons if we want to turn the airplane left, roll into a left bank? Well, we use our handy-dandy yoke control in the cockpit, and so we're going to turn that to the left just like we do with the steering wheel in a car. And what's going to happen is the left aileron, I am doing this wrong. The left aileron is going to get deflected upwards, and the right aileron is going to get deflected downwards. And so you're going to produce more lift on this side of the airplane, and so the airplane is going to roll into a left bank. That is how an airplane is controlled via its elevators. Now, there is a problem. Let me just tell you a really cool trick if you want to remember which one gets deflected up and down. It all depends on where your thumbs are pointing. So if you point your thumbs to the left, that means the left aileron is going to be the one that's thumbs up. That's going to be pointing upward. If you do it the other way around, your thumbs are going to be pointing at the raised aileron on that side. So that's just a helpful memory aid. But there's a problem that we encounter when we try to roll the airplane into a left turn, because remember, when you're producing more lift, you're also going to produce more drag. Drag is always there trying to mess our game up, and the effect that this has is that this side of the airplane is going to go a little bit slower than this side, and so this kind of counteracts what we're trying to accomplish here, and we call this adverse yaw, because the airplane, you roll it into a turn, but this side starts producing more drag, and so the plane yaws in the direction opposite of the turn. And this is not coordinated flight, folks. We do not want to be flying in a skidding turn. We need to get that nose to follow the airplane around in the turn. So what do? That's why we have our rudder, and we have this wonderful thing in the back. So just looking at it from the top view, here's the airplane and our wings and stuff. And so our rudder also has that hinged surface in the back, and we can deflect it against the airflow. And so we want to turn left, so we're going to push on the left rudder pedal. So here's a representation of that. We're pushing on the left rudder pedal, and the air is going to be hitting against that deflected surface, and that's going to turn the airplane nose to the left. It'll make the tail swing that way, and so the nose will come to the left, and that's how we coordinate our turns. That way, we're going to have the airplane turning as well as banking. Alright, so that's how we overcome adverse yaw, and it's something that actually becomes more pronounced when you're flying at lower airspeeds. And so you're going to have to use more control deflections, and here's actually something that I need to point out. And when you're flying the airplane, you are actually going to be able to feel your controls. The faster you're flying, the faster the air is flowing over the control surfaces, and so you're going to feel the controls firm up as you get faster, and it'll take less actual movement of the controls to produce a big reaction from the airplane. And so we don't fly control movements, we fly with control pressures. We exert pressure on the controls, just enough pressure to get the right response from the airplane. And as the airplane gets slower and slower, the controls get sloppier and sloppier, and you're going to feel that you're going to have to move them a lot more in order to get the enough pressure on the controls. So that's how airplane controls feel when you're flying. Now, there's one other control that we have to coordinate our turn with, because remember, the nose is going to start dropping and the airplane won't hold its altitude when you enter a turn, because not all your lift is acting completely vertically anymore. So what do? We need to somehow get that nose back up, and that is how, and we do that with our elevator control. So here is the airplane from a side view now, and here is our elevator. That's actually the horizontal stabilizer part of it, and back here is the elevator part. And so what do we want to do? Let's say we want to bring the nose up, so we're going to pull our yoke back, and that is going to deflect the elevator upward. And so that is going to make the tail want to fly down, and that will bring the nose up. Opposite is true if you want to bring the nose down. So you push forward on your yoke control, that will deflect the elevator downwards, and so now this back wing over here is going to be producing more lift than it was before, and so it'll have an upward force on the tail. If you bring the tail up, you're going to bring the nose down. Okay, so that is how we can control the airplane with our elevator controls. And so we have just talked about all three primary controls. Now we're going to go into the secondary controls. And to kick off secondary controls, let me tell you about a design variation of the elevator. Now you have, okay, here's the, ooh la la, my drawings seem to get progressively worse. You have a normal elevator design where you have the stabilizer and then you have the hinged surface, which is the elevator part of it. Well, what some aircraft designers have done is they have decided that instead of having a hinged surface on the back, they're just going to make the whole entire stabilizer be able to move. And so they put the hinge right here, and you can actually... And so instead of having a separate elevator attached to the horizontal stabilizer, the whole horizontal stabilizer itself can move up and down. And they have a cool name for that. It's called a stabilator, because it's a stabilizer and an elevator in one. What do you know? A stabilator. Okay, now there's a tendency for pilots to over-control the airplane when you have a stabilator, because you have so much more surface area now that you're working with, that's being deflected against the airstream. And so in order to keep pilots from over-controlling, they actually make it harder for pilots to put a lot of control deflection. And the way they do this is they put something called an anti-servo tab at the very end of the stabilator. And it's almost like a little tiny elevator, except you don't have independent control over it. And this is what it looks like. So it's right there, and it's this very small tab at the very end. And the way it works is you have the air flowing over, okay, and so when you pull up and you deflect that whole stabilator upward, that anti-servo tab actually goes even further, and it makes it more difficult for the pilot to be exerting that pressure on the controls, because the air is going to be hitting it more, and it's actually just going to want to push it back down. So that's how aircraft designers make it more difficult for the pilot to deflect the stabilator too much, because we don't want to over-control the airplane, so they put it in this anti-servo tab. And if you deflect the elevator in the opposite direction, it also deflects even more in that direction, and it makes it harder to push too far forward. So that's anti-servo tabs. Now we can understand our secondary controls. So we've talked about the primary controls, which is the elevator, aileron, rudder. Now we're going to go into something called trim. And trim is very important for pilots' quality of life, because you have just taken off your airplane, you've climbed up to cruise altitude, and you've leveled off, and now you're trying to hold your cruise speed of 100 knots, and you notice that in order to keep your altitude at whatever, 3,000 feet or whatever, as your airplane has picked up speed, the nose wants to come up. You're having to hold all pressure against the controls, and you've got a 3-hour flight in front of you, and you don't want to have to hold pressure on the controls for that whole time. And the reason you're holding pressure on the controls is because you have your airplane's going faster. You're producing more lift on the wings, and so you have to lower the angle of attack so that you don't climb. So what do? That's what we have trim for. You have a little wheel in the cockpit that you can rotate, and this will actually change something on the elevator so that it will hold it in the position that you want without you having to exert pressure on the controls. And let me just show you what this looks like. So here is our here's our elevator again. We're back to talking about elevators because we're not talking about stabilators anymore. We're just talking about regular run-of-the-mill elevators. Okay, so here's the hinged surface part. And remember the anti-servo tab? Well, we have something called a trim tab that we can work with. So the trim tab is a little insert right there, another hinged surface. And what it looks like is this. So here's the elevator part, and at the very end is the trim tab. And very simply how it works is if you're flying along and you have the trim tab set at an upward angle, what's going to happen is, while the elevator is hinged, and so because the airflow is striking the top of that trim tab, it's actually going to end up deflecting the elevator itself downwards. And so now it's going to hold itself in this position in the airstream all by itself without you having to do that. And so that's how the pilot can hold the elevator controls without actually having to hold them. He'll set the trim wheel, and so it'll exert this aerodynamic force, and then it'll just kind of reorient itself in the airstream, and then you can fly the airplane hands off. And now you can enjoy your 3-hour flight without having to hold pressure on the controls for that whole flight. Of course, the airplane is always going to need retrimming because some little thing will change. You'll burn off more fuel. Somebody will shift around in their seat, maybe move their seat back, and so the airplane will be a little bit out of balance again. But this is how we can make flying a lot easier by changing the trim tabs. You'll have trim tabs on the elevators for pretty much every plane. You can also have trim tabs on the ailerons because some airplanes might have a little bit of tendency, if you're burning fuel on one side, that wing will get low, or that wing will rise up, and so you'll be having to hold aileron control into that side. So you'll have aileron trim. You can also have rudder trim. But for the airplanes that we're going to be flying, most of them are just going to have elevator trim. What they might have is something called a manual trim tab for the rudder. If you're flying along in flight and you notice that that the airplane kind of tends to yaw off to one side, then you have this little thing, this little tab that you have to set manually on the ground, and it's just trial and error. You come back from a flight and say, okay, the airplane was kind of yawing a little bit to the left, so I'm just going to bend this thing to the right. So you'll see this on a lot of training airplanes, this little manual trim tab, bendable trim tab on the back of the vertical stabilizer. Okay, so that's trim tabs. So that's one of our secondary controls. The other one that we're going to talk about is flaps. And we've all seen flaps when we've ridden on commercial airline. You look out the side, out the window at the wing, and during approach to landing, it's like the whole wing starts unfolding, and it's quite an impressive sight. And that's because they're lowering the flaps. Very simply put, a flap is basically like almost like a one-way aileron or something. You deflect it downwards. And this one right here that I'm drawing is just called a plane flap. not like an airplane flap. It is on an airplane, but more like plain and simple, because there's 4 types of flaps that we're going to look at here. This is the plain flap, and simply speaking, a flap will increase the amount of lift that the wing is producing. At the same time, it's going to move the center of pressure back a little bit, and so if the center of gravity is over here and you move the center of pressure back, it's going to have a little bit of a nose down moment. That's an effect that you'll often have with the airplane. So that is the plain flap, and this, when you lower the flap, it increases the camber of the wing, and so it's able to produce more lift at the same angle of attack that it's flying at. So that's the benefit of flaps, and that's why we use them during approach to the landing, because the airplane is flying slower. We want to be able to produce more lift and have a reserve of lift while we're landing. That's the plain flap, so let me just write that down there. And then another type of flap that you got is the split flap, and so it's just the bottom half of the back of the wing that comes down, and that tends to produce more drag. This also produces drag. All types of flaps produce drag, especially the more that you lower it, because you see it's almost like a big old scoop that you're creating right there. So this tends to produce more drag than you really like, but that's the split flap. And then you have something called a slotted flap, and this is kind of cool, because when you lower the flap, you open up this slot, and so air that's flowing underneath the wing is able to rush up through here and accelerate the air that is on the top of the wing, and this enhances the amount of lift that you're producing. And so that's the slotted flap. And then a variation of the slotted flap is called the Fowler flap, and this is what we've seen on the commercial airliners. The whole big old deal actually extends on out to the back, and so not only is it slotted, it also increases the effective surface area of the wing, and if you've got more surface area, you're going to be able to produce more lift. So these are our flaps. There's also stuff that you can call that is called leading edge devices that help produce more lift at slower airspeeds. You might have a slot on the front of the wing, and where the air is able to let me improve my drawing here. Yeah, you might have a slot on the front of the wing that opens up when you're going at lower airspeeds, and that helps the air accelerate from the bottom over to the top. Kind of similar to this, but we really don't fly those kinds of airplanes when we're training. But just so you know about that, there's also leading edge flaps where this will extend out like that, and that also helps produce more lift at slower airspeeds. And alright, so we have learned about the primary flight controls and the secondary flight controls. So primary flight controls, you got elevator, aileron, rudder, and secondary controls are the trim, and trim is very helpful. Learn how to trim your airplane because it'll save you a lot of effort. Anyway, trim and flaps. Flaps help us on approach to landing. Now just remember, the more flaps you deploy, the more drag you're going to be producing as well. And that can give you problems when you're trying to go around from a aborted landing. If you have all those flaps hanging out in the wind, you need to start retracting them a little bit at least, so that you don't have so much drag preventing you from climbing. Okay, so that is flight controls. There's a lot of other stuff that an airplane has in it, and that makes it go and that helps it to operate, and that's what we're going to be learning about in the next lesson, Chapter 6 of the Pilot's Handbook of Aeronautical Knowledge, Aircraft Systems. Let's learn about systems, and that will be next time on SkyBound on the Ground.